Welcome back to Caffeinate Math. In this video series, we're making sense of the normal distribution and the z-scores. This is part 2. Are you ready? Let's go. In the last video, I introduced you to the z-score and how this simple formula can take any normal distribution and point it back to just one, the standard normal distribution or the standard normal curve. It has a mean of 0 and a standard deviation of 1. I think the easiest way to see how it works is just with an example. So we're going to dive in. Here's our problem. Samantha graduated from college 2 years ago, and she now earns $50,000 as a high school math teacher. Nationwide, the mean salary for teachers with a bachelor's degree is $35,000 with a standard deviation of $8,000. How does Samantha's salary compare to the national mean? First, we draw a picture, and we're going to add in the information we know. So we have a nationwide mean of 35,000 and a standard deviation of 8,000. And we know that Samantha's salary of 50,000 is above the mean. And now we'll bring in the z-score formula. So we plug in the numbers we know, and we get 50,000 minus 35,000 divided by 8,000. Plug and chug that, and we get z equals 1.875. Great. So now what? Yeah, what do we do with that z-score? I'm going to show you two ways to approach this. The first way is with an old-fashioned z-chart or z-table. The second way is with software. We'll start with the z-table. So here's our problem again with Samantha, and let's zoom into the z-table. Our z-score is 1.875, and just looking at the first two digits, we see 1.8. So we need to find that on this column here. Then we find the last part of the number, 7.5, up on this row. We'll have to round it to 0.08. Then we see where these two intersect, and here we are. The z-score corresponds to 0.4699. Well, what does that mean? This z-score tells us the area between the national mean and Samantha's salary, which tells us that almost 47% of math teachers earn a salary somewhere between the national mean and Samantha's salary. If we look at the entire area below Samantha, we just have to add in the 50% on this side of the curve. So 0.5 plus 0.4699 is 0.9699, which means that 97% of teachers make less than Samantha. So we can see she's doing quite well in the education sector. I'm going to show you the same problem again using software to solve it. In this case, we'll use the Microsoft Analysis Tool Pack for Excel, which is just a free add-on. Still the same problem, but if I open up Excel and in one of the cells I type in equals norms dist, and then the z-score in parentheses, it comes out with 0.9697. Now notice it automatically showed me the entire area left of Samantha's salary. Also notice that these two numbers, well, they aren't quite the same. But remember, when we used the z-chart, we had to round up a bit. So really, we're pretty close. Let's try another example. This time we have Candela. And Candela also graduated from college 2 years ago. She also earns $50,000, but as an accountant. Nationwide, the mean salary for an accountant with a bachelor's degree is $60,000 with a standard deviation of $5,000. How does Candela's salary compare to the nation's mean? Again, we'll start by drawing a picture and adding in what we already know. A national mean of $60,000, standard deviation of $5,000, and we can see that Candela's salary falls below the national average. So let's use the z-score and see how she really stacks up. Plugging our information into the equation, we get 50,000 minus 60,000 divided by 5,000 is -2. Okay, so now what? Well, we'll start by pulling up the z-table and finding our associated probability. Now, don't worry about the negative right now. We'll just find the 2 here and then, well, 0.0 here. Find where they intersect, and voila, we see 0.4772. So back to the problem. A z-score of -2 corresponds to a 0.4772 probability. So 47% of accountants earn between what Candela earns and the national average. If I subtract that from 0.5, I get 0.0228. So that means that just over 2% of accountants earn less than Candela. Looks like she has some room for advancement in her career. Using the Excel analysis tool pack again, I type in the same thing, equals norms dist, and in parentheses the z-score, and we get just over 0.02. Remember, the Excel tool pack always shows you the probability to the left of the mean that you're studying. So using the software or the z-table, it's your choice. You just have to know what number each is telling you. So that's it, the crash course on the z-score. Next up will be the t-distribution, and that has a really cool story that goes along with it. Thanks again for sticking with me, and I'll see you next time.